Oke, Assalamualaikum warahmatullahi wabarakatuh. Uh, First of all, thanks to all the organizer which has organized this conference, and then all the people which involved in this research. Our research, titled Long Short-Term Memory, or LSTM, based architecture for forecasting tourist arrival, done by us. The lead of the researcher is Bapak Harun Mukhtar, and then all the researcher member, Muhammad Akmal Remli, Khairul Nizar Shahzwan, Wan Salihin Wang, and me, Yose Rizki. I would like to start the presentation. The arrival of foreign tourists to Indonesia will increase the country's foreign exchange, so it is important. The tourism is very important for us. With so many tourists coming, it will have an impact on the income of the community around the destinations. So the people are also happy if the tourist comes. Calculating the number of tourists who will come in the following year is important because it can anticipate the negative impact that will occur. For example, if I am the business owner which have a product of souvenirs, I sell souvenirs to the tourists, and I make a lot of souvenirs for next year. A lot. 1 million souvenirs. I produce 1 million souvenirs for next year's. And suddenly next year, no tourists coming, no one's coming, only a few tourists coming to my shop. So I will be I will I will lost. I will get so many negative impact for my business because nobody coming to my shop. That's the why the calculating the number of tourists is important for the businesses, because it will anticipate the negative impacts like that. So we have aims here to evaluate the performance of LSTM introduced by Hackright. Hackright has introduced the LSTM before. And the previous research discussing tourist visit to Indonesia has been done by Hafiluddin and A. Jawahir. They obtained that RBFNN, or radial basis function neural network, is more efficient than ARIMA. Now we will add Hackreight's LSTMs to compare with those methods mentioned before. So we will compare the LSTM result to the RBFNN and ARIMA result. LSTM results would not be optimal if they only use the small amount of data. In the study of Peng et al., index data and historical data was used, and LSTM is optimized with random forest and differential evolution. So the combination of random forest and differential evolution to the LSTM outperforms several other machine learning methods. So it has good result. We hope that adding index data and historical tourism arrival data can improve the performance of LSTM to forecast the tourist arrival in Indonesia. So the methods are this: the data, we collect the data from the government agency, Indonesian Central Statistic Agency. So it is a valid data because it is from the government itself. The data set, we split it. The test data has 55 rows and the training data has 714 rows. The data can be accessed publicly in this GitHub link. If you have the file, the presentation file, you can click it. And the architecture itself was built using 50 neural units in one hidden layer, and configure the training process, and we can calculate the loss percentage with mean squared error. So we will use MSE to calculate the loss percentage. This is the the diagram itself. We will start and we input the dataset and pre-processing it, and then we will train the data with the model, and we will evaluate the performance. LSTM itself has 13 steps. The first is frames the sequence of learning problems by creating input. The second, dividing the data sets, namely determining the range of interval from the length of the data. And the third, it returns a different value. Fourth, determine the training scale and test scale using the min-max scalar module with a range between -1 to 1. Fifth, create an inverted scale or what is known as the normalization to determine forecasting values. Sixth, adjusting the LSTM network with training data. Seventh, make prediction with one step. Eighth, turning data into supervised learning. Ninth, separating data into training data and test data. And the 10th, changing the scale of the dataset, create a fit model by estimating the entire dataset to build a forecast state. In this step, we create the model. And then the 11th, validating the test data. And the 12th, comparing actual data with predictions. And the 13th, evaluate using the RMSE, MAPE, and MAE. So when processing the data, the experiment uses data on the monthly arrival of foreign tourists from 2006 to 2021. So that the results obtained are specific, we will divide them into 4 pieces of data. We will compare the result of the 4 data to get which data is the best data. These 4 data consist of, the 4 data are first data from 2006 until 2019 with zero. Zero means with zero. There are some countries with has no tourists coming to Indonesia. We will exclude the some zero value of this data set. The data for 2006 until 2019 with zero, the data for 2006 to 2019 without the zero, we will exclude it here, include the zero data here, and exclude the zero data here in the bottom. And then the third data is with 2020 and 2021. So there are 2 years, so it's 2020 and 2021, which has an effect of COVID-19. So we will exclude it in the first data set, and we will include the 2021 and 2020 and 2021 data here. The third data is 2006 until 2021 with zero value, and the last data is 2006 until 2021 without the zero value. Data for 2006 until 2019 and data for 2006 until 2021 are compared because there are specific differences that I said before in values, whereas in 2020 and 2021 there is a very large decrease in the number of foreign tourist arrival. So we will include the data and exclude the data of the 2 years of COVID era. COVID-19 does not allow people to come to this country. Then why does it have to be divided between zero and no zero? In this case, we want to know whether the value of zero, it means zero. There are some countries with zero tourists coming, especially in 2000 and 2020 and 2021 when there was a COVID. So in this case, we want to know whether the value of zero will affect the prediction or no. Oh, sorry. So this is the graphic. So we use the number from each country tourist. So there are some countries with zero, with no tourists to go to Indonesia in some years, and we will conclude and we will include and excluding the we will separate the data with COVID and without the COVID years. So there are some tests with 2020 and 2021, and there are data without the 2020 and 2021. The results are like this. So this at the top is the 2006 until 2019, and in the bottom of the table there is data result from 2006 until 2021 with the COVID. And this is dataset with value of 0 including, and dataset without value of 0 including. The value of 0 is excluded. So we have this as a result. In the years of COVID, if it's included in the data like this, the MAPE was quite high. So there is a high error. But the MAE and RMSE is quite low, so it's good, but the MAPE is high. And if we exclude the COVID years, the 2020 and 2021, the MAPE is quite low here, but the MAE and RMSE is quite high. It can be concluded that the 2006 until 2021 dataset without 0 gets the best score for RMSE and MAE, but for MAPE, the 2006 until 2019 dataset with 0 gets the best score. Research that discuss tourist arrival to Indonesia use LSTM, which can be applied to annual forecasting. The the partial use of the datasets for 2006 until 2019 and 2006 until 2021 is very good. When the dataset is large and does not have a value of 0, it is evaluated with RMSE and MAE, getting the best score, even though the scores in the MAPE evaluation are quite high. Uh, Based on this result, we have concluded the MAPE is not suitable for use as an evaluation, but RMSE and MAE are very useful. That is the result of our research. Thank you so much for your attention during my presentation. Assalamualaikum warahmatullahi wabarakatuh.